In this lesson, we're going to be talking about wireless tools. Now, there are a lot of different wireless tools that are available. One that's really useful that can run under Windows as well as Linux is one called AirCrack. And AirCrack actually comes with several companion tools, and I'm going to show you some of them here right now. So the first thing I want to do is show you Airmon. And what Airmon does is it gives you the ability to set a monitor mode on your wireless networking device. So I've got Airmon NG. I could do Airmon NG start, and my interface you see up above is WLAN 0. Now what this is going to do is put the wireless networking device into a mode so that you can see a lot of traffic that you wouldn't otherwise be able to see. So this is similar actually to promiscuous mode on a traditional network interface where suddenly you're getting packets that you wouldn't otherwise see because the network interface wouldn't pass them up the stack without being set into promiscuous mode. So the same thing here, I'm going into monitor mode so that I could actually see the layer 2 messages, which are the communication between the network interface and the wireless access point, or just communication from the wireless access point from a standpoint of either broadcast or beaconing. I'll show you beaconing in just a second. So let me actually bring up our old friend Wireshark here. And once I've loaded up Wireshark, we can actually start to see the messages that are coming in on the wireless interface. You can see under the capture box down here, it says Start Capture on Interface WLAN 0, which is actually the physical interface for the wireless adapter that I've got. And there's also MON 0. Now, MON 0 is the interface that was created when I turned on monitor mode. If I were to just capture on WLAN 0, I would see traffic that was going back and forth on my wireless network. So messages to and from me, just like a normal network interface. Now, if I go into MON 0 and start capturing there, now we start to see the beacon frames. So you can see a beacon frame here. Now it says protocol 802.11. 802.11 is the IEEE standard for wireless networking, and there are a number of protocols that are associated with 802.11. Traditionally, you will see 802.11 and then a letter. So there's 802.11a, b, g, n. Those different letters indicate not only the bandwidth that you may be able to consume, so like G, for example, is a 54 megabit connection. B was an 11 megabit connection, and N gives some capacity for much higher means of communication, so you get much higher bandwidth with 802.11n. So we've got 802.11, a beacon frame here, and you can see there's a destination address of FFFFFFFF and a source address of a Netgear. So there's also a BSSID, and that also is a set identifier, much like the ESSID. And now I've got the 802.11 wireless LAN management frame, and you can see there's a timestamp there and a beacon interval. We've got capabilities information, so this is a bunch of flags that get sent out, and you can see the transmitter is an access point. Transmitter does not belong to a BSS. And what else have we got? Short slot time in use. And that's all that we've got here. Now for tagged parameters, you can see the SSID parameter set, and that gives you the name of the SSID. We've got supported rates. I can do 1, 2, 5.5, 11, 18, 24, 36, or 54 megabits per second. So those are all of the different rates that I have available on this particular access point. So this is the beacon frame that I mentioned earlier, where a wireless access point is announcing the SSID that it has available for people to connect to. Now, the thing you're not seeing here is the other wireless network that I have available here where I am. And that other wireless network has a hidden SSID. In other words, I'm not broadcasting it, which of course is why you're not actually seeing those messages. But you are seeing these beacon frames on a pretty regular interval. There's no chance that somebody's going to come in here with a wireless device and not be able to see that this SSID is available. Now, again, as mentioned previously, this SSID happens to have open authentication, so there's actually no encryption going between the access point or the base station and the network interface card. So we'd be able to see all of the communication going across the network between the access point and other stations here. Now, one of the advantages of going into monitor mode on a wireless network interface like this is I'd be able to see communication with a rogue access point, or I'd also be able to see frames that were going across at a layer below where I would normally see. So if I were looking for maybe authentication attacks against the access point, I may be able to see those going on. But going into monitor mode is going to give you the ability to look at things on the network in a way that you wouldn't otherwise be able to see, so that you can see maybe different attacks that are going on. Now, the other thing you can do with monitor mode is I could actually start grabbing packets. So let me quit this. And now I can do air dump or arrow dump. And in this case, if I can get to the right spot here. So I've got arrow dump. And what arrow dump is going to do is it's going to read a bunch of packets off the network. I'm going to say output format is PCAP, and then I want to say WLAN 0. Actually, let's do MON 0. So what this is going to accomplish is it's going to copy a number of packets down, and once you get enough packets copied, you can actually run aircrack against this particular file that you've got. So I'm going to store a lot of packets here. I could run this for several hours and just capture gigabytes worth of data, and then I could run aircrack against it. And with the large volume of data, particularly if you're running WEP, although potentially against WPA2, aircrack could be able to infer what the encryption key is for these packets. And once we know what the encryption key is, we can start to decrypt packets. So we can start to see all of the communication on the network that's going on in plain text. So I'm running arrow dump here, and you can see it's counting the beacons, and it's also showing the different stations that are available here on the network. It looks like there are 3 networks that are available, or at least 3 networks that somebody is looking for. This is another use of this particular suite of tools, where you could run this after setting the device into monitor mode, and you could see all of the different probes that are going on in your network. So again, you see somebody is actually looking for this network 09FX03031109, which would suggest to me it's some sort of wireless access point that probably comes with a router, and this is just the default name for the SSID. It's hard to say for sure what this actually belongs to or why this is being probed, but you can definitely see that it's out there. Now, you can also see there's a BSSID noted up above, and you can see encryption is flagged as open, and I've also got the SSID or the ESSID that's associated with that particular network that's available. So we've got a pretty powerful suite of tools here with AirCrack. And as I said, it's available for Linux or for Windows. It's open source. You can download it. The only challenge with running this is ensuring that you have a network interface that is actually compatible with AirCrack, and it's a device that you can actually put into monitor mode. So you probably want to look up the documentation before taking a look. Now, there are a number of other tools that are available. This isn't the only one. There's a tool called Kismac, which does some similar sorts of things. It will actually go looking for networks that are available close by. And Kismac is a Mac port of a program called Kismet that runs under Linux, so you could grab Kismet as well. Now, there used to be programs called NetStumbler and some other Wi-Fi analyzers. There's actually a tool called Wi-Fi Explorer that you can use under the Mac, and there are several for Windows that are available as well. And with these, you can actually go digging for information about the various wireless networks that may be close by within range. And again, you can start to see what's going on locally and see whether there are rogue access points that are available that may be providing access into your enterprise remotely without you being aware. So a lot of tools are available for exploring wireless networks and seeing what's going on. And of course, there's also tools that are available for trying to crack encryption on wireless networks, and that's something that you should be aware of as well.